Okay, so today we're going to start the geometry unit, which begins with finding the area of parallelograms. We are going to start first by naming some figures that we're going to see in the unit. So if we look at each of these shapes, you'll see this first one is a triangle. It has 3 sides. It includes a right angle, which a right angle is a 90-degree angle, and it looks like that perfect capital L in that corner. So this is a triangle, but specifically, it is a right triangle. Okay, the next figure we see is a parallelogram, and that's what we're going to be looking at today. Now, in a parallelogram, the opposite sides are parallel. And I'm going to make these 2 lines. That's the symbol for parallel. So what that's saying is this side and this side are parallel to one another. If I were to continue drawing these lines on forever and ever and ever, they would never ever touch. That's what parallel means. And the same thing with these opposite sides. This side and this side, if I were to continue drawing those on forever and ever and ever, they would never touch each other. So that's what a parallelogram says. The opposite sides are parallel. Now the next figure is also a triangle. This triangle, if we look at all of the angles, they're all what we call acute angles, angles that are less than 90 degrees. So we call this an acute triangle. Okay, and then the next one we have, hopefully you recognize, this is a rectangle. What makes a rectangle is that it has 4 90-degree angles. Opposite sides are parallel, so this side and this side would never touch, this side and this side would never touch, and they're also equal. So this is the same length as this side is the same length as this side. The last figure here is a trapezoid. In a trapezoid, it has exactly 1 pair of opposite sides that are parallel and 1 pair of opposite sides that would intersect. So these 2 sides are parallel. So 1 pair of opposite sides, parallel, 1 pair, it would intersect. So if I continued these lines going on, they would never touch, but these lines, if I continued them on, eventually, because they're kind of slanted towards each other, they would eventually hit. So that is a trapezoid. So those are just some figures we're going to be talking about in the unit. The next thing we're going to do is we are going to plot some points on this coordinate plane. So I gave the kids some points to plot. So I will just write those out. We have -2, 3, -2, 9, -7, 3, and -7, 9. So we're going to start with those 4. So to plot these, if I were to go over to -2, up to 3, that would be my first point. Over to -2, up to +9, over to -7, up to +3, and then over to -7, up to +9. So I have created a rectangle. Okay, so if I draw my lines in here, this is what I have. Now, hopefully we all know how to find the area of a rectangle, and to do that we would do the length times the width. So if I count the distance between these 2 points, I can count the lines, or I can do my distance based off of my 2 points. So if I have between here and here, it would be 1, 2, 3, 4, 5 units. And then if I do the other side, I have 1, 2, 3, 4, 5, 6 units. So the area of this would be our length times our width, or our 5 times our 6, which would give us 30. Okay, so the area means that there are 30 squares inside this rectangle. Now, if we were to shift the rectangle into a parallelogram, so what this is saying is if I were to take this point and shift it the same number of units that the length of this line is, so if this is 5 and I shift and make 1, 2, 3, 4, 5 points away another point, and I just use these same right here, so now I'm changing it from this point to this point, and then I do here to here and here to here. I'm not changing the area of my problem. So this is 5, and then I'm using this line, or 6, to get my 30. So what I'm actually doing for a parallelogram is I'm doing what's called the base times the height of the parallelogram. So I'm still going to do 5 times 6 to get the area of this figure. It's very difficult to count when you have these little half, quarter, third fractions of a square inside them. So to find the area, I'm just shifting that over. It's still going to give me the same length, and I just use the height. So now I'm doing my base times my height. So the area formula for a parallelogram is area equals base times height. So if you can find the base and the height, you can find the area. So let's look at another example. So if I want to plot another figure, 3, -1, 7, -1, 2, -6, and 6, -6, I would go over to +3, down to -1, over to +7, down to -1, over to +2, down to -6, so 1, 2, 3, 4, 5, 6, it's hard to read the numbers, and then 6, -6, 1, 2, 3, 4, 5, 6, down to -6. So now what I've created is a parallelogram. So I can connect my lines. So I can easily count what's called the base here. I can go 1, 2, 3, 4 over, so my base would be 4. Now to find the height of a parallelogram, you have to go from one side to the opposite vertex at a right angle. So I'm going from my base up to the other side, and it has to form a right angle. So my height has to come out. I can't use this as my height because it's not creating a right angle with my base. Okay, so if this is my base, to make the height, it have to come out from a right angle to the opposite side. I could come out here, I could come out here, anywhere that's going to create that right angle that I need to be able to count my height. So now I would count 1, 2, 3, 4, 5 as my height. So to find the area of this parallelogram, I would do area equals base times height. My base is 4, my height is 5, so 4 times 5 gives me 20. Okay, so we're going to look at some more examples. So now what they want us to do is, if given the base, they want us to draw the height. Now, like I said on the previous page, the height comes out of the base at a right angle. And remember, a right angle is a 90-degree angle. Now, it goes to the opposite side, okay? So if I wanted to do the base, and typically I would go to the opposite vertex. So I would go to a point on the opposite side, and I need to come out of the base at a right angle. So if I come down here, this would be considered the height there. Now, sometimes you're going to actually have to draw outside of the figure. So with the next one, I could do my height like this. Also, I can work within the figure. However, if I look at the next one, this final one here, if this is my base, I can't make it to the opposite side at a right angle. all of them would have to be kind of diagonal lines. So what this means is when you can't come from the base to the opposite side at a right angle, you're actually going to draw the height outside of the figure. To do that, what you do is you draw an extension of your base, and notice I'm using a dotted line because it's not part of the figure. It's an imaginary line that's going to help us to find the height. I'm going to go down from this corner, this vertex here, to create that 90-degree angle that I need. So in this problem, this would be considered my height. So it's sometimes going to be outside your figure. Now you can still do that with other ones that you can do within, so I can still continue that dotted line and have this be the height, and this length should be exactly the same. Same up here, I can extend it a little bit if I needed to make my height outside, and this length would be exactly the same. Okay, so now we're going to look at finding the area of some parallelograms. The important thing here is that you're going to see there's more numbers than what we need to use. So we have to make sure we're actually using the base and the height. So the first thing I would do is I would write that I'm doing area equals base times height. I'm not given the area here, so I would rewrite the A. I need to find my base and my height. Now, remember, your height comes out of your base at a right angle. So you can always look for a right angle, as seen here, and those two will connect your base and your height. I always think about it, if I have that right angle symbol, one side of it is touching my base, one side of it is touching my height. Now, the base is always a part of the figure, okay? So this line is a part of the outside of that parallelogram, so that 6 would be my base. The 4 is not actually a dimension, or is not actually part of the outside of this figure, but it is my height. A lot of times you're going to see the height as this invisible drawn line. So my height would be 4 here. Now, the 5 is the length of this side, but it is not the height because it's not coming out of the base at a right angle. So this is a number that we don't need here. If I wanted to find the perimeter of this figure, I would need that number because I would add all the sides together. But in this case, I don't need it for this problem. Okay, so in this case, 6 times 4 is 24. They're centimeters, and again, area is always square units, so it would be square centimeters. I would be able to fit 24 squares of centimeter dimensions in here. Okay, looking at the next one, again, I'm going to do area equals base times height. I'm looking for my base. So this would be considered my base right here because, as you can see, out of it, here's my right angle, touches here, touches here. So this is my base, part of the figure. And my height comes out of the base at a right angle, which would be this 8 right here. The 10 is just that side length. I don't need that in order to find the area. If I wanted perimeter, I would use it. However, here, I'm not going to use that. So then I would do my 25 times 8 and get 200 square, in this case, it's meters. Okay, so you want to make sure you are using the base and the height, not a side length. Okay, so this is just a side length. It's not my base and it's not my height. Those two should meet at a right angle. Okay, so now this one says if the area of a parallelogram is 35/42 square centimeters and the height is 1/7 centimeters, write an equation that relates the height, base, and area of the parallelogram. Solve the equation. So we'll use our area equals base times height. Our area this time is given to us, so 35/42. We are given the height, which is 1/7, and we're trying to determine the base. Okay, so this is just a multiplication equation, which means I'm going to solve it by using the inverse operation or division. So I'll divide both sides by the number that's attached to that variable or being multiplied by that variable. So I will divide both sides by 1/7. Remember we said these two would cancel each other out. 1/7 divided by 1/7 is just 1, and 1 times b is b. So those two cancel out, leaving us with the variable, which is what we're trying to determine. So now I'm going to pull to the side and do my 35/42 divided by 1/7. Now I'm going to use the multiply by the reciprocal method. So I'm going to keep that 35/42 the same. Instead of dividing by 1/7, I'm going to multiply by the reciprocal of 1/7, which is just to flip-flop those numbers. I like to cross simplify, so I see that 7 and 42 can both be divided by 7. 7 divided by 7 is 1, and 42 divided by 7 is 6. So I'll multiply across. 35 times 1 is 35, and 6 times 1 is 6. Now I can leave it as the 35/6 because 35 and 6 do not have a common factor, or I can turn it into a mixed number. 35 divided by 6 is 5, and then there would be 5 left over because 6 times 5 is 30, and then the denominator stays the same. So either one of those would be the correct answer there.